Hey there, and welcome. Let's talk about the world of science for a minute. What do you think makes a research paper truly, massively influential? Is it a huge, groundbreaking theory that completely changes how we see the universe? Or could it be something else entirely? Well, today we're going to dive into this and uncover the really surprising truth behind what makes a scientific paper a greatest hit.
Right, so when you think of science's greatest hits, names like Einstein, Darwin, they probably pop right into your head. I mean, these are the rock stars, the names we all learn in school. But does being famous in a textbook actually equal having the most influence in the lab? That is the mystery we're about to solve.
So I want you to just pause for a second and think about it. If you had to put money on the single scientific paper that has been referenced more than any other by scientists themselves, what would it be? What discovery was so fundamental that it became the ultimate building block for future research?
Okay, if your guess was something like Einstein's theory of relativity or maybe Watson and Crick's work on the structure of DNA, you're in really good company. I mean, those are the paradigm-shifting ideas that literally reshaped our world. They're the logical guesses, the intuitive answers, and yeah, they're all completely wrong.
The real champion, the undisputed king of scientific citations, isn't some grand sweeping theory. Nope, it's actually a pretty humble, practical paper from way back in 1951. You could basically call it a laboratory manual, and it has quietly blown every single one of the giants out of the water.
So, what's this paper even about? The title is Protein Measurement with a Fallen Phenol Reagent. Yeah, I know, it doesn't exactly roll off the tongue. It sounds super specific, really technical, right? It's all about a hands-on method. And yet, this paper by Oliver Lowry and his team holds the all-time crown.
So just how influential are we talking? This one paper has been cited over 350,000 times. Just let that sink in. According to the Web of Science database, that is far and away more than any other publication in the history of science. It's an absolutely staggering number.
So what does it actually do? Well, in the simplest terms, the Lowry paper is a recipe. That's it. It's a super reliable, easy to follow, step-by-step guide for a basic lab task, figuring out how much protein is in some kind of liquid. It's not a revolutionary idea, it's a revolutionary method. It was a tool that pretty much every biologist on the planet needed.
And this right here, this is the main takeaway. The most cited papers aren't always about the biggest, most mind-blowing ideas. Instead, they're the papers that give scientists the most useful tools, the hammers, the wrenches, the software that they need to make their own discoveries.
You know, this pattern shows up everywhere. You look at the top 100 lists and you see it over and over again. The Lowry paper is a basic lab measurement. Other huge papers give scientists statistical methods for crunching their data, or they describe a key piece of software. These things are the plumbing, the absolute infrastructure of science.
A really great way to think about it is that these papers are kind of like viral recipes. You know, one person posts a simple, reliable, delicious recipe online, and then suddenly millions of people are using it in their own kitchens. Well, these papers gave scientists a simple, reliable method they could use in their own labs every single day.
But hold on, the story doesn't stop there. For decades, these classic lab methods have been sitting at the top of the charts, but now that whole landscape is changing, and it's changing at a breathtaking speed. There's a whole new generation of tools that are shaking things up.
Get this. A paper on artificial intelligence from a 2015 conference, written by some Microsoft researchers, has already become one of the most cited papers in history. This isn't a biology method anymore. It's a computational one, and that signals a massive shift in the kinds of tools that are driving modern science.
This timeline really puts that insane acceleration into perspective. Lowry's paper had more than 70 years to build up its lead and become number one. This AI paper, it's been out for less than a decade and has already cracked the top 10. The pace of scientific influence is just getting dramatically faster.
And it's not just that one AI paper. This change is happening all over. In fact, 16 of the top 50 most cited papers of all time are published in the 21st century. I mean, think about that. They've had so much less time to rack up citations, but they're already outperforming classic papers that have been around for over 50 years.
So the big question is, what's behind this incredible change? Why are modern papers climbing the charts so much faster than the old ones? Well, the answer really comes down to two things: the sheer volume of science being done and the incredible speed at which it's all being shared.
Just look at this comparison. Back in 2014, if you wanted to get into the top 100, your paper needed about 12,000 citations. What about today? That number has skyrocketed past 30,000. The price of admission has more than doubled in just a decade. It just shows how much more competitive things have gotten.
So what's feeding this beast? Well, it's really a perfect storm. First, there's just an explosion in the number of research papers getting published every year, which means more chances to get cited. And on top of that, the internet has been a total game changer. Online databases, even social media, let important new methods get found and shared across the globe, basically instantly.
All of this brings us to a new way of thinking about what a citation really means. We have this tendency to think it's a measure of pure genius, but the story is, well, it's a bit more complicated. It seems to be less about a single brilliant idea and more about its broad practical usefulness.
This quote just nails it. A high citation count doesn't always point to a world-changing idea. More often than not, it points to world-changing utility. It's about how useful something is to other people.
So here's the bottom line. Citations absolutely measure influence, but that influence usually comes from providing an indispensable tool, a recipe, a statistical test, a piece of software that lets thousands of other scientists go out and make their own amazing discoveries.
And that leaves us with a really fascinating question to think about. If the main way we measure impact, citations, is best at finding the most useful tools, then how do we make sure we're also recognizing and rewarding the great foundational ideas? As science keeps getting faster and faster, figuring out how we measure what truly matters, well, that might be one of the biggest challenges of all.